today's objective, we're going to be solving absolute value equations and inequalities. We're doing both in the same objective. The processes are very similar, but there are slight differences, so make sure you're paying attention to whether we're solving an equation with an equal sign or an inequality with a greater than or less than sign. So the definition of absolute value is the distance or the number is away from 0. So absolute value should not be a new word to us. Remember, absolute value, we use long bars to represent absolute value. So our first example is the absolute value of x equals 5. So we want to know what number could x be so that it is 5 spaces away from 0. So if we think about a number line, we put 0, what number can x be so that it's 5 spaces away from 0? Well, if I have 1, 2, 3, 4, 5, okay, that could be my x because it's 5 spaces away from 0 in this direction. But I can also go the other direction, 1, 2, 3, 4, 5 at -5, which is also 5 spaces away from 0. So really, we're saying what is all of the possible values that x can be, and there's going to be 2 because there's 2 directions on a number line, so there's going to be 2 values of x that satisfy every absolute value equation. So we could say, well, I know whatever's inside of my absolute value bars either has to be -5, because that's going to give me 5 spaces away, or has to be +5, because that's going to give me 5 spaces away. There's a few different ways to write this answer. You could say x equals -5 and x equals +5. We can consolidate that and just write it as plus or minus 5. Then a fancier and more technical notation is using our curvy little brackets, and we put -5 and +5. All right? We do not want to use parentheses because that's telling us it's an ordered pair. This is not an ordered pair. The brackets are telling us that -5 and 5 is the solution set. We call that a solution set to the equation. Right? So it's pretty clear when we just have one thing inside of our absolute value bars, because we can see it on the number line. We can count 5 spaces, 5 spaces. It's a little more difficult when we have other things inside of our absolute value. The next example, we start to see absolute values. And we have our multiple things inside of our absolute value. So again, if I have my number line, I want to find something that's 7 spaces away from 0, because I'm saying that the space is 7. But I'm not just saying x, so I can't just pick the number and pick the number like I did in example 1. I know that whatever is inside my absolute value, this whole thing is either going to be 7, because the absolute value of 7 gives me 7, or -7. So I use that idea that whatever this thing is has to equal 7 or -7 so that I get this answer. So I set up 2 equations to help me find it. This red bubble, x minus 5, either equals a +7, or the red bubble, x minus 5, equals a -7. So now I just solve to find my x. I add 5 to both sides, add 5 to both sides, and I get x equals 12. Or, for my second setup, I add 5 to both sides, and I get x equals -2. So here I have my 2 solutions, or I can write it in my solution set as 12 and -2. Okay. But what does this mean? Well, let's plug it in and check our work. If x is 12, Then I have the absolute value of 12 minus 5. And we're hoping that equals 7. And the absolute value of 7, yes, does equal 7. That works. Right? Over here, we have negative 2 minus 5 should equal positive 7. And here we get a negative 7, but yes, negative 7 is still 7 spaces away from 0, so this also works. So this should make it a little more clear that when you're plugging your solutions or substituting your solutions back into the original problem, we start to see that even though we have two very different numbers, the two different numbers do give us the absolute value that we're trying to find. All right, so let's try another example. So far, we've had all of our work done inside of our bracket, and now we see a more challenging example where there are things outside of our absolute value bars. All right. Before we even start thinking about what's going on inside, we need to worry about this 8 and the 6 out in front. All right. I like to call these prison problems. So we imagine that 4m plus 8, they're in jail. All right, they're in the jail bars. And they can't break out because over here we have guards. And our prisoners are not going to try and break out in front of our guards. That would be ridiculous. They're going to get caught. So we need to get rid of our guards before we bust out of jail. Now, since we are solving for m, we want to look at our GEMDAS, right? And solving, we go from the bottom up. So I need to get all of my guards away in the order of GEMDAS. So is there any addition or subtraction? Right? A common error is that we add 8 plus 6. Right? There are no parentheses here around 8 plus 6. So we don't want to add those two. We need to solve by using the opposite order of operations. So yes, I do have addition that I need to get rid of. This 6 is actually being multiplied in front of the absolute value bar, so we can't add those two things together. So how am I going to get rid of my 8? Well, it's a positive 8, so in order to undo that addition, I'm going to subtract 8 on both sides, which leaves me with 6 times the absolute value of 4m plus 8. And 104 minus 8 is 96. And now I need to isolate my people in jail. So I need to get rid of this guard. How do I undo this guard? Well, I undo multiplication with division. And now I have my jail all by itself. 96 divided by 6 is 16. And now I have a problem just like number 2. I know this entire bubble, my red bubble, has to be 16 spaces away from 0. So this either has to be 16 spaces away on the positive end or 16 spaces away on the negative end. So I set up my two equations. Once I've gotten rid of all the guards, 4m plus 8 equals 16. And the negative version, which is 4m plus 8 equals negative 16. And we solve, try and find our solutions. So I subtract 8, I subtract 8, and I get 4m equals 8. Divide, divide. So my m is equal to 2 is one of my solutions. And I need to find my other solution. I subtract 8 and subtract 8. I get negative 24. Divide by 4, divide by 4. And m is equal to negative 6 is another solution. And we could go back and check our work. all the way back in the original equation to see that, yes, it does actually give me 104 in both cases. All right, so the next example is our inequality. What happens when we have inequality symbols? Well, there's a few things. First, we need to realize that, again, we have people in our jail, but there's this guard hanging out below. So I need to get rid of my guard, again, by using the opposite order of operations. Right? Do I have any addition or subtraction? No, but I do have multiplication and division. I actually have division. So how am I going to undo division? I multiply by 5 on both sides. So there I get rid of my guards, and now I have the opposite of 9n inside of my absolute value, which is greater than or equal to 10. Here's the trick that we have to remember, which is a key point of our inequalities, right? When writing two equations, right, you need to flip the sign for the negative equation. Right? So just like we did with our equations, we do the same thing for inequalities. I know that this bubble, in order to have the absolute value to be equal to 10, whatever was inside the bar either had to be positive 10 or it had to be negative 10. Right? And this negative 10 part is where the key point comes in. So I can write my positive example just like it is. Negative 9 is greater than or equal to 10. Now my negative example, I want to write negative 9n, and I flip the sign. So instead of saying greater than, I'm going to put less than or equal to, and my negative 10. Right? So whenever you have this negative part of your equation, you should also be flipping your sign, and that's what the key point is referring to. Now, this is where it gets tricky. You flip the sign to set the problem up, and then we solve. So I divide by negative 9, I divide by negative 9. What happens when I divide a negative number and I'm dealing with an inequality? I flip the sign again. So now I have 9 is less than or equal to 10 over 9. There's one solution. Now here I have negative 9 divided by negative 9. Even though I already flipped it when I set it up, I'm dividing by a negative and I can't change the rules of math. I still have to follow that rule. So I'm just going to flip it back the way it was. And I'm going to have n is greater than 10 over 9. Alright, so those are the examples for your notes. You need to complete the next 3 examples in your notes as a self-check. We will be putting these answers on your do now at the start of class, so these need to be completed. If these problems are not completed, you will be earning a LaSalle. So please complete the self-checks. If you need to go back and rewatch the video or check back in your notes, it's more than acceptable. We just want to make sure that you understand the notes, and we'll talk about it tomorrow.